All right. So ladies and gentlemen, what we have here is we are going to solve the system by substitution. Now, this we could solve by graphing, right? It's the same thing. But rather than getting out graph paper and trying to do all the graphing method, we can also use an algebraic method. Okay? Now, the important thing is still we're going to have our consistent, inconsistent solutions, dependent, and independent. And I'll kind of talk about those. I'll kind of talk about what those different solutions mean algebraically. But in the substitution method, we want to use the substitution method. The best time to use substitution is when, you guys might want to write this down. I'm not going to write it down for time purposes. But whenever you have a variable that is solved, or meaning anytime you have a coefficient for one of your variables, that is either 1 or -1. So you guys can see right there, y has a coefficient of 1, right? So mentally in my brain, I'm going to want to use substitution. So anytime you have a variable that has a coefficient of 1 or -1, Lizzie, it is going to be beneficial for you to use substitution. Make sense? So how do we use substitution, and why is it important when we have a coefficient of 1? The reason being is because whatever variable has a coefficient of 1 or -1, and even if you have 2 of them, just pick which one you want to solve for. But this is the only variable that has a coefficient of 1, correct? So what I'm going to do is I am going to solve for that variable. Because when it has a coefficient of 1, I don't need to undo multiplication or division, right? I just need to undo addition or subtraction. So I'm going to subtract a 2x from both sides. Therefore, now I have y equals -2x plus 4. So now I'm just going to rewrite my system. It's 3x plus 5y equals 13. And then y equals -2x plus 4. So basically, when we're doing substitution, we want to be able to have it written with a variable isolated. All right? And you can do this when it's not equal to 1. But then you'd have to multiply. Then you'd have to undo multiplication or division. So it's easiest when you have a variable that has a coefficient of 1. So now, if you guys remember when we did functions, if I had f of x equals 3x minus 5, and I say find when x equals 2, or I said, they would say f of 2. Now, what did we do with the 2? You put it in for the x, right? Yeah. So you did 3 times 2 minus 5, because x was equal to 2. 2 was equal to x. You could replace them or substitute one for the other, correct? Now we're doing something very, very similar. Now y is not equal to a number, but it's equal to an expression. But we can still substitute in that expression in for the variable. So that's exactly what I'm going to do. I'm going to substitute in my expression in for y into the other equation. So I have 3x plus 5 times -2x plus 4. OK, Jade? Got it? You doing all right? You doing OK? OK. Does everybody see what I did? This is the big step right there. Now, the reason why that's so important is because now I have created an equation that only has one variable, x. Yes, it has 2 of them, but I'm only dealing with x. I'm not dealing with x and y's. So now I can solve this. This is a multi-step equation. I can solve this. So I apply distributive property. So I have 3x minus 10x plus 20 equals 13. 3x minus 10x is -7x plus 20 equals 13. Subtract 20, subtract 20. -7x equals -7. Divide by -7, divide by -7. X equals -1. Positive 1. Thank you. -7 divided by -7 is positive 1. So does everybody see that? Now I know the value of x. But again, when we're solving, remember when we did the intersection? We had a x and y coordinate where they intersected, right? So we had x was equal to y. So now I'm going to take my value of x and plug it in for x. So I have y equals -2 times 1 plus 4. So y equals -2 plus 4. Y is equal to 2. So now I know the value of y, and I know the value of x. Now, on an equation, if you were to think about this graphically, if we know the x and the y coordinate, that represents where they intersect, right? So then what kind of solution? Is this consistent or inconsistent? consistent, right? And they're going to intersect at the coordinate point 1, 2. So it's a consistent, independent system, right? Because they only intersect at one point.